PAHTCF based on PA12, but is it better than PA6? And why this may be a good material for these buckles? Hello, welcome to my tech fun, to another BambuLab filament testing video. This is PAHTCF, carbon fiber reinforced high temperature nylon. And I have here two spools because one I bought myself and the other was sent by BambuLab in a big box maybe half years ago together with other filaments, and somehow I forgot about it, but it's time for the testing. This is not cheap filament, approximately $50 for half kilogram spool. These are 1 kilogram, so don't be confused. And it is based on PA12. And compared to PA6, PA12 has a lower sensitivity to the moisture, great mechanical properties and great layer adhesion, high tensile strength. It is compatible with 0.6 mm nozzle but 0.2 not, and of course we need hardened steel nozzle because of those carbon fibers. And interesting information, it is AMS compatible. AMS Lite not, but the reason for this probably that AMS Lite you are using with A1 or A1 Mini, which are open printers, and this required enclosure. Drying is very important, so I will dry it before the use because every nylon always dry before the use, and also the printing will be from the filament dryer. Print settings: the nozzle temperature between 260 and 290 degrees Celsius, the bed between 80 and 100 degrees, and the speed maximal 100 millimeters per second, but of course I will use the default settings in the Bambu Studio for this filament. Let's open one box. It's seriously protected during shipping. This packaging is really great against the moisture and it is resealable on this side. Typical bamboo spool at the maximum temperature for the drying is 90 degrees Celsius. End of the filament is glued, but let's see how brittle is the filament. Very minimally, let's measure it. The start angle 25 degrees. And it broke, I think, on 100 degrees, but I will check the footage. And it's not even completely broken. It's important to mention, even if this nylon type is less sensitive to moisture, it still absorbs some water from the air, even the printed objects, not only the filament. So after the printing, I will wait at least 10 days, and during this it will be closer to the stable state, and only then I can start the mechanical testing. These are my regular test objects. Let's see the default settings in the slicer. 290 degrees Celsius on the nozzle, 8 the maximal flow rate, and here you can see the default part cooling. I can start the printing. I already mentioned that even the printing will be from the filament dryer on X1 carbon using engineering plate with some glue on it. Printing is at 40% and looks completely okay so far. Last we vertically printed test object and the printing is quite fast. The bed completely cooled down and the object looks really nice. Okay, they are removable thanks to the glue. And only after 10 days I will start the mechanical testing, but first I want to check the dimensional accuracy, and I will measure above the elephant foot. Wow, this is really accurate. These are buckles with the same dimensions like with that PCTG video. I just want to compare to see how they perform. Only later I decided that I will need glue for the annealing, so that's why some testing will be done separately. Annealing will be 1 hour inside this Sunlu E2 filament dryer. It's finished the cool down with the dryer. At the first look, no deformation, promising. Well, actually on this one test object I can see some minimal warping, which I noticed later. My original plan was to wait 10 days after the printing, so they will get closer to that stable state, but I checked the footages and exactly 1 month later I'm starting with the testing. Tensile test with horizontally printed test objects. These are annealed versions. Good to see they are stronger. Interesting to see that annealing helped here. The improvement is approximately 13%. And I will include some data for the PAHTCF from my earlier video. This is the non-annealed version. layer adhesion with vertically printed test objects, and the annealed version. Big improvement. Again, we can see big improvement with annealing, approximately 36%, and this also confirms that dimensional accuracy and stability, there are no micro warpings inside, which will make this layer adhesion weaker. But even non-annealed version has good layer adhesion according to my rating. Shear test horizontal and vertically printed test objects. For the horizontal one, just in case I use the stronger equipment. PA6 is stronger again, but this time the difference is not significant. The torsion or twist test with horizontal and vertically printed test object, and I'm starting with horizontal one. One. 1.9. Vertical. Whoa. 1.3. More than 90-degree rotation with this vertical test object, not really typical for 3D printed parts in this test. Well, this time the PS6 is noticeably stronger, but what was very interesting is this almost half turns with vertically printed test objects with PAHT. Impact test with this half kilogram hammer. Zero position. Actually, it was broken when the hammer swings back. And by the way, nobody answered me, what is this new machine? Nobody can recognize it. Patrons, you asked for it. Analyzing the footage, I can measure the distance from the zero position, and then I can calculate the breaking energy, and this is one of the toughest carbon fiber reinforced filaments I tested so far. 3-point bending test, the annealed version is on the right side, distance between supports is 50 mm, and I'm placing these loads one by one, and I'm measuring the deformation after 1, 30 and 60 seconds, and currently you can see the deformation under 10 kilograms. In both cases, there is no big difference from the annealed version, and the PS6 is stronger in this test, less deformation, but what I don't really like with the PAHT is this constant deformation during this 1 minute, even under 5 kilograms. Definitely you don't want to place a higher constant load on this material. The creep tests the deformation under constant load, and I have several tests in the progress, this time all black filaments, PPS-CF, PAHT-CF, graphene reinforced PLA, and graphene reinforced PETG. The load is 1.25 kilograms. Interesting, surprisingly small star deformation on these two. 12.30. This is surprisingly good for the PA12. 13.12. It had very minimal initial deformation, but even on the last day it had some minimal creeping, and that's why I want to reprint this one and check if annealing helps. Pity I didn't do this together with the regular materials, but later I decided to anneal these test objects to see if it will be better on this creep test. The circumstances are the same, only it will have different company. These are carbon fiber ABS materials. Day 5, time for the measuring. 13.08. We can see that annealing reduced a little bit the deformation, but the difference is not big. And basically these two lines are parallel with each other. And we can see some constant deformation even on day 5. It's not big, but it's still there. And the difference between 2 days, the creeping, we can see actually on the second graph, and they are almost identical in both cases. The temperature test in the oven I did separately. I adjusted these two videos side by side, and in both cases they start to deform on 217 degrees Celsius. Only this surface on the annealed version started to destruct very suddenly, but even then this is very temperature resistant material. It's cleanable. And our results on one place one more time. Tensile test, layer adhesion test, shear test, bending deformations after 30 seconds, bending deformations after 130 and 60 seconds, twist test, impact test, and the temperature test. I started with thinking, why do we have this PA12? Because PS6, even if it is more sensitive to moisture, but even in a wet state, in most cases it is stronger than PA12, except that PA12 is tougher material, that's a good property. And I started with analyzing datasheets from different companies, and this is my conclusion. Much lower moisture absorption, which will result in more consistent mechanical properties, better dimensional stability, less moisture and less over-extruding because of those micro drops in the nozzle, reduced warping and curling, this means easier printing, longer shelf life, less drying before the next printing, and improved resistance to the fatigue, UV exposure and chemicals. And this resisting to the fatigue is something I never tested on this channel, so I think it's time to create some new equipment. You know, this is the property of the material to keep the mechanical properties for the repeated loads. So that's why maybe this material is a good recommendation for these buckles, which we don't have constant load, but this repeating may reduce the mechanical properties. Big thanks to all my Patreon supporters. From their donations I can create all this crazy testing equipment. And to all you others, well, thank you for watching this video. See you in my next one, and happy printing. Ah yes, wait, let's break this. Gift for those who are still watching the video.